Hi there, folks. Today we're looking at geometric series. And a geometric series, just like an arithmetic series, it's a series. It's a pattern in which we're adding all the values of the pattern together, but it's specifically following a geometric pattern, okay? So when I look at the terms of a series, if they represent kind of a geometric sequence when I just look at the terms, well, then it's a geometric series, okay? So if I'm getting from one term to the next by multiplying by the same thing each time, that's a geometric series, okay? The only difference between a sequence and a series, once again, a geometric sequence, I just have the terms listed, but a geometric series, I'm going to add those terms together, okay? And so here's the formula for finding the sum of the first n terms of a geometric series. So again, I'm only going to look at a piece of the geometric series here today. And so when I look at that piece, I want to look at, okay, from this value to this value, I want to add those up, okay? And so this is looking at a certain number of terms in order to add together here. Okay? And so once again, S sub n is the sum based on the number of terms equals a sub 1, which is the first term, times 1 minus r to the n over 1 minus r, where r, remember, is the common ratio. It's the thing you're multiplying by each time. And n is the number of the number of terms that we're going to add together. Okay? And what's nice about this formula, even though it looks much worse, is there's more of that standard information. When you think about arithmetic series, sometimes I had to go find things like a sub n. Okay? And here a sub n is not part of the formula, so there's less things that I typically have to go and find. That's not to say that I won't ever have to go find things. Sometimes I'll be missing like the n value and I'll have to go find it. Okay? And so something like this guy, I have to go to the other formula just a little bit less, okay? There's less scenarios in which I have to do that. If I look at something like this guy, it says find the sum of the first 17 terms. And so for this one, I'm just going to plug it into the formula. It's S sub 17 equals, and maybe I should write the formula off to the side over here. So S sub n equals a sub 1 times 1 minus r to the n all over 1 minus r, okay? And so I just plug this in. I say, okay, a sub 1 is a 2, so that's a 2, times 1 minus r this time. To get from one term to the next, I'm multiplying by 2 each time, so that's a 2. N is the 17 because there's 17 terms, all over 1 minus r, which once again is the 2, okay? And this becomes a job for my calculator. I just have to be really careful about parentheses here. When I plug this into the calculator, I'm going to need some parentheses around this denominator right here, and parentheses around the entire numerator as well, okay? So just keep that in mind. If you're going to punch it in all in one shot, you're going to have to use a few parentheses here, okay? And so let me punch this into the calculator. And when I punch it in, I get let me switch back to blue. I get the sum of the first 17 terms equals 262,142. That's it, okay? We punch it into the calculator. We be careful about the parentheses. We make sure order of operations are being followed. And that's it. We plug it right in, okay? If I look at this guy, once again, I want to find the sum here. So the formula is S sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. And I just start plugging in what I know. I start with this and I say, okay, S sub n, well, I don't really know how many terms this is, so I'll leave the n blank for a moment. A sub 1 is the 160 times 1 minus r. R this time is a 1/2 raised to the n, which I still don't know what that is yet, all over 1 minus r, okay? And so as I look at this thing, I'm looking at it going, well, I don't know how many terms that is. Well, anytime we're missing something, we just have to go back to our other formula. We have to go to our formula that says a sub n equals a sub 1 times r to the n minus 1, okay? We have to go back to this formula and say, okay, I want to find the n value. I've got this guy, 160. I've got r is the 1/2. N is the thing I'm looking for, and I want the value of n. I want the number of what term? Well, the 5 over 64, okay? And so once again, this is just me going through and solving things that I've already done before, okay? Anytime I'm missing something from one of these formulas, I go to one of the other formulas. I go to something that I already know how to do. I find that missing value, all right? And so for this guy, I'm going to divide each side by the 160. And we can use our calculator for that. It's 5/64 divided by 160 is the same thing as 5/64 times 1 over 160. And we could reduce the 5 and the 160. And if I do that, I should get 1 over 2048. And up from here, I have a choice to make. I can get common bases in order to solve this thing, or I can use logarithms to solve this thing. I think most students prefer just to throw a log at this thing because, well, there's no guess and check involved here, okay? Not many of us know 2 to what power gives me a 2048 off the top of our heads. And so getting common bases might require a little bit of guess and check, but using logarithms, well, this cancels out, and it's just something I can plug into the calculator now, okay? And so when I plug it into the calculator, once again, it's going to be the natural log of 1 over the 2048 divided by the natural log of 0.5, okay? And when I do that, if I punch it into the calculator, it gives me an 11. I add that 1 to each side, so n equals a 12, all right? And here's the thing. That was quite a bit of work to get to that, but now all I have to do is come back over here and use that 12, okay? S sub 12 equals, this is now a job for my calculator that I can plug right in, okay? Once again, just be careful with the parentheses here as you plug it in, okay? And as I plug it in, as a decimal, this thing's going to give me a 319.92. If I wanted the exact value, well, then I'm going to have to kind of approach this by hand a little bit. So let's work that out as well. If I wanted the exact value, 1/2 to the 12th power. That gives me a 1 over 4,096. Okay, if I do 1 minus that guy, oh, sorry, I should have this whole thing over 1 minus 1/2, which is 1/2. Now from here, that's 160. This is going to give me a 4095 over the 4096. And I could deal with that 1/2 right now if we want. The 160 divided by 1/2 is like times 2, so that's a 320 out here. And now it's just a matter of reducing the 320 and the 4096. I can reduce those to a 5 and a 64. And now, of course, I can do the 5 times the 4095. Okay? So working this thing out, I get 20,475 over a 64 when it's all said and done. Okay? So there it is as in exact terms. Okay? And yeah, if I ask for it in exact terms, yeah, you might have to do a little bit of fraction work. Okay? So again, that sum formula, a little bit more complicated, a little bit more involved, but we plug in what we know. If we're missing any values, we go to the other formula, we find it, and then we finish plugging this thing in. Okay?